All right, we're going to start today's lesson 1-9, and today's lesson is an open response lesson where you're going to have to do some deeper thinking and do some designing of things that are a little more, they're going to require a little bit more thinking before you'll be able to do the assignment today. So we're going to go ahead and model some things with histograms. You're going to be designing those today to end up trying to get your viewpoint across to somebody. So we're going to kind of model through that a little bit and how different histograms, by changing bin sizes and things, you can kind of make it look different to get your point across that you want to get. So in this case, study the histograms beforehand. They're both talking about final exam scores. It's the exact same data, okay? But in this case, the bins go by every 10%, 20 to 30, 30 to 40, etc. And here the bins are 25%. Fall in those bins. So they look a lot different even though this is the same data. So let's describe the situation in the histogram on the left over here. Okay, in this case, a lot of the data is accumulated over here on the right, and we talk about these shapes, and it's actually skewed to the left because there's some outliers that really make it go far to the left, which skews this data a little bit. So to describe it, and if you understand that this is skewed, we can use that technical word. It's skewed to the left because most of the data is here, but then there's some outliers that skew that down. Remember, it kind of looks like a hill. In this case, it's going to the left because most of the data is over here on the right where most of the kids scored. If I describe the distribution in the histogram on the right here on number 2, when the bins are like this size going by 25s, it looks a lot different, and there really isn't a shape that describes this that we learned. It's really odd shape, but you know, you could just describe in words. It's flat for a while, then rises quickly and flattens again. Okay, so again, there's not really a name for that one. It's not a normal one we would see. Okay, so sometimes you just have to describe it. Why are these graphs a different shape? Okay, because it's given the exact same data. So why are they a different shape? Because we have different bin sizes. And when you change the size of those bins, we've learned that that's going to change the way this would look, and we can try and get data and persuade people and get it to look the way we want it to look to get a point whatever cross we're trying to get across, that point we're trying to get across there. So it looks a lot different when I change those bin sizes, and this is very evident in this example right here. How many test scores are represented in each graph? And if I look at these graphs here, we can figure out how many fall into these bins, and you could use either one, you'd get the same answer. So 2 people fall into this bin, scoring between 0 and 25%. So you've got 2 here, 2 here as well. Here we're up to 17 that fall in this bin, and 18 that fall in this bin. So we could add all these up. And I'll just do 18 plus 17 first is 35, and then 4 more is 39. I like to do it with these bigger bins because it's less numbers I've got to add up. If I did this, I'd have all these different bins to add up. If you did that, you'd get the same thing though. There are 39 test scores of kids represented here in these graphs. How do you define the number of test scores? I just counted up the number in each bin. Okay, and again, that will tell me how many are in there. Counted up the number in each bin. All right, so we should be able to estimate some information here too and really understand what's going on with our data landmarks. Okay, so the mean, mode, median, and range we're trying to figure out here. So let's start with the mean and the average. And one of these graphs for certain ones might be easier to find using that than the other one, so we'll kind of talk through that a little bit. But the mean here, the average, you see most of the kids fall between this 80 and 90 range in here. But notice it's skewed to the left. And remember, when it's skewed, the data is going to, these outliers are really going to skew that average down a little bit. So the average probably isn't going to come up in here because we have so many kids on this side and a big outlier. So I would probably say it's going to fall somewhere, and again, this is just an estimate. You can't tell for sure because you don't know their exact scores in the histogram, but maybe 70 or 75. It's going to skew it over to here somewhere. There's a lot of kids in this one, so it's not going to take it clear down to here because a lot of kids were in this area, but maybe, 70% or so, so around 70 could be a good estimate. Okay, 70 to 75. You can vary a little bit there, but you can estimate it's going to be around there somewhere. Okay, the median, again, is the one in the middle. And with our median, we kind of got to determine where that middle might be. And that's a little bit different because in this case, you have 39 kids we know have taken this. Okay, so 39 kids, we need to find the middle one. Okay, so the best way to do that maybe is cut that in half. So we know half of 39 is around 18. So if I can get, where's the 18th kid fall in this case? So I kind of have to count up the bins here. So I'm going to erase some of this stuff here. And it'd probably be easier to use this one to see where it falls, because I know there's one kid here, 2, and we're looking for that 18th kid. He would be the middle one. So there's about 3. Another one is 4 and 2 more. So we're at 2, 3, 4, 5, 6. 6 and 6. Now we're up to about 12. I think I'll start totaling here. We've got 12 kids. And then here we've got, kind of messy there. We've got 9 more. So 12 plus 9 would give me up to around 21. So somewhere in this bin, that middle kid would be somewhere between 70 and 80. We don't know for sure. So we probably put between 70 and 80. The middle kid would fall in there somewhere because we're looking for about that 18th, 19th kid, and they would fall somewhere in here at this bottom range probably, but we don't know where all those percents landed, so you can't say for sure. If you tried to figure it out over here, it'd be a lot tougher because there's such a range in here that I wouldn't know exactly what to guess. So I can get a little bit closer here in these smaller bins. The mode, most, which one shows up the most? In this case, I'd probably use this one as well because I see a lot of kids scored between 80 and 90. So I would say the mode, if there is one, is going to be somewhere between 80 and 90. And over here, it'd be harder to tell because there's so many in there and so many spread out, so you wouldn't be sure. The range, again, we know is the difference between the greatest and the least. And again, I don't think this one would tell me a whole lot because it goes from 100 all the way down to 0. But if we look over here, this one starts at 20. So here, the greatest one, again, could be close to 100. Remember, if it's 100 though, if it was above 100 or above, it would probably go to the next bin. So technically, it'd probably be 99. But to estimate, we can say 100 down to 20. So 100 minus 20. Range would be somewhere at about 80% difference between the highest and the lowest. And again, we know we have that outlier, one person who scored really, really low that caused us to have a really big range there, be somewhere around 80%. So if you wanted to argue that the students did pretty well, which graph would you use to support? I would probably use this one because when you look here, you see all these kids that score between 70 and 90 and a few up to close to 100, and you see that big chunk. If I'm using this one, I don't know, 50 to 75, I don't know where those kids fall. In the 75 to 100, they could all be around 75%. We don't know exactly without any other data, so this one would be hard to tell if I only had this. But when I have this one to look at, I can see that these kids actually did pretty well. There are just some outliers here that did a little bit lower. So that's probably what I would write something to that effect if I were going to answer there number 6. You guys now are going to be designing your own histograms for a situation in an open response lesson. Where you're going to have to design and decide how big to make your bins. And you can see easily from these examples it really changes the way the data looks. So you will be doing some work with that on your own and maybe with your groups a little bit to try to design your own and more understand these histograms a little bit better.